Sir Isaac Newton's laws of motion are used to explain the relationship between force, motion, acceleration, mass, and inertia, and they are the foundation for classical mechanics. They were first described in his book, The Mathematical Principles of Natural Philosophy.
Isaac Newton was born in 1643 in Lincolnshire, England.
In his book, Newton wrote that there were 3 laws of motion. The first law stated that an object does not change its state unless an exterior force is applied. His first law also says that an object at rest will remain in rest. Newton's second law of motion states that the mass of an object is directly proportional to the force required for acceleration. Finally, Newton's third law states that every action has an equal and opposite reaction. Later in this video, we'll cover the second and the third laws, but for now, let's just focus on the first one. The first example of Newton's law is found in the game of hockey. If you slide a hockey puck on the ice, eventually it will stop because of friction on the ice. It will also stop if it hits something, like a player's stick or a goalpost. Another example of Newton's first law can be found in the theory of kicking a ball in space. If one were to kick a ball in space, it would keep going forever because there's no gravity, friction, or air resistance going against it. It will only stop going in one direction if it hits something such as a meteorite or if it reaches the gravity field of another planet. Moving on to the second law of motion, this law basically establishes the relationship between acceleration and mass in order to find force. This relationship basically presents itself in the equation of F equals m times a. We can use Newton's second law of motion in this example to figure out how much force a person needs to exert on a car for it to move. By using our equation, force equals mass times acceleration, and plugging in 1,000 kilograms for the mass and 0.05 meters per second for the acceleration, we can find that the force needed to move the car is 50 newtons. Newton's third law establishes that for every action there is an equal and opposite reaction. We can explain this third law with the balloon example. When air rushes out of a balloon, the opposite reaction is that it flies up in the opposite direction. There's even an example of Newton's third law in our classroom.